Percent yield is the comparison between the theoretical yield and the actual yield. The theoretical yield is the amount of product formed when the limiting reactant is completely used up. So the theoretical yield is how much we've calculated we should have produced. The actual yield is how much is actually produced in the experiment. Hopefully you've realized already in your labs that you don't always get the exact amount that you think you should get. And that's just through human error, waste, and other issues that laboratories have. So the percent yield, you want to be as high as possible. Typically it's not 100% because you're going to lose some product along the way. So the theoretical yield you have to solve for by doing math, and the actual yield has to be told to you, or you in lab have to weigh that and get it off the balance. The formula for calculating percent yield then is the actual yield divided by the theoretical yield. And because it's a percent, we're going to multiply it by 100. That also means that there's no units to go along with our answers because you're dividing and multiplying by 100. Now, should you get a number more than 100? No. If the actual yield is more than the theoretical yield, that means somehow you've contaminated your product with other things. Something was added to your products that shouldn't have been there. So when you're working these problems, you really shouldn't have a percent yield greater than 100. If you do, then something's wrong with your numbers. Most likely you're dividing upside down. Alright, so our problem here. If 4 grams of water produces 0.67 grams of HF, what is the percent yield? Alright, so even though we're given two givens, this is not a limiting reactant problem. And it's not a limiting reactant problem because 4 grams of water is a reactant, but this 0.67 grams of HF is my product. So that's not a limiting reactant problem. That is a percent yield problem because we're talking about a product. So the first thing I want to do is figure out my theoretical yield. So I'm going to take my 4 grams of water and see how much of my HF I should get. So there's no coefficients given to us in the problem, so we need to double check that this problem is balanced. So I have 2 carbons and 2 carbons, 1 fluorine, 1 fluorine. 3 and 2 make 5 hydrogens. 3 plus 1 is 5. And then I have 2 oxygens and 2 oxygens. So in fact, yes, it is a 1-to-1 ratio. So 1 mole of water is 1 mole of HF. And because my product amount was in grams, I want to make sure I convert that to grams. So 1 mole of HF is 20 grams of HF. Now that tells me, after I multiply and divide, that I should have 4.44 grams of HF. So that is my theoretical yield. So I'm going to take my actual yield that they told me, 0.67 grams, divide it by my theoretical yield, 4.44 grams, and I have a multiply it by 100, and I have a percentage of 15%. Well, 15% is really not good, and if you were working in industry, you'd be in a lot of trouble for only having 15% yield. Alright, so then we come down here. If we started with 28 grams of water, and it produces a 79.6 yield, how many grams were actually produced? How many grams are produced? So let me figure out theoretically how much should have been produced. Same process, taking our grams of water to grams of HF. So theoretically, we should have produced 31.1 grams of HF. Alright, so I'm going to use an X for my actual yield. My theoretical yield is 31.1 grams times 100 equals 79.6%. So then it just becomes an algebra problem, and we're going to solve for X. So divide by 100, multiply by 31.1, and our X value would be 24.8 grams of HF. So that was the amount that was actually produced in the problem, in the lab. Alright, you have one more problem left in your notes. I would like you to finish this as part of your homework.